So we're on number 1 for 6.2, and it's tasked me to find the dot product. If I look at my little half sheet of paper, I see the dot product is V times W equals A1 A2 times B1 B2. Okay, so that's the formula we're using. We're going to write it a little differently. For one thing, we don't have V and W, we have U and V. And we're going to think of this one as U times V, and this is A1 B1 A2 B2. So my A1's multiplied together. You can think of this as your x's multiplied together, plus our b's, or we can think of it as our y's multiplied together. So if we actually do this, our A1 will be negative 8 times 3 plus negative 1 times 1. Multiply those two together. Negative 24 plus negative 1, so minus 1, gives me negative 25. I want numbers 2, 3, and 4 are exactly the same, so I'm going to skip down and do numbers 5 and 6. So you can pause right here if you want to go ahead and try those next three. Where do I want to clear all? Oh, let's just get rid of that. Alright. So for number 5, it looks a little different because there's just an I, just a J. Well, remember we learned last time I can change this to component form. If I change it to component form, there is no I, so the I term would just be 0, 9. And for this one, the I is 9, the J is 0. So that's what that looks like in component form. If I do that, then I say, oh, multiply these two together. 0 times 9, so A1, A2, plus multiply those two together. B1, B2, 9 times 0. And of course, if I do that, 0 times 9 is 0, 9 times 0 is 0, 0 plus 0, 0. That's my answer. I don't have to actually change them to component form, and I'm not going to bother here, because I know here's my A1, here's my A2, there's my B1, there's my B2. I'm going to multiply my two A's together, multiply the two B's together. 9 times 2 is 18. Negative times positive is going to be negative, so plus a minus, or minus. 4 times 5, 20, and that should give me negative 2. Alright, so problems 7 and 8 are just like that. So if you want to pause the video here, you can try those, and then I'm going to move next on to problems number 9. Alright, to find the measure of the angle between two vectors, U and V, we're going to use our formula that says theta equals inverse cosine And it says on the paper it says v dot w. We're going to use u dot v over the magnitude of u times the magnitude of v. So the first thing I need to do is the top, that is dot product. Alright, so what we just finished doing on the first page. So dot product, multiply those two together, negative 3, and I'll move this off to the side, and say this is u dot v, negative 3 times 5, plus, multiply those, negative 7 times 2. So negative 15 plus, actually, well, plus negative 14. So really negative 15 minus 14 is negative 29. So there's my dot product. Bring this back for a second so I switch colors. Alright, so that was the top. We need to find the magnitude of each one. So magnitude of u is the square root of negative 3 squared plus negative 7 squared, which is 9 plus 49, or the square root of 58. Magnitude of v, square root of 5 squared plus 2 squared, 25 plus 4, or the square root of 29. So these are all my individual parts. So now I can plug in to my formula and say, try to pick a different color. Theta is the inverse cosine of u dot v. I already found that. U dot v is that negative 29. And then the magnitude of u, well, that was square root of 58. And then magnitude of 29, we'll put this in parentheses, and square root 29. And then I can plug that into my calculator just the way it is. A different one. If I plug that into my calculator, oh, didn't change colors, I should get rounded 135 degrees. Okay. So a few different steps there, but really all we did was find the magnitudes of both vectors. We found a dot product, and then we just plugged into our formula and then plugged into the calculator. So number 10, 11, and 12 are exactly the same way. Number 13 on is still actually the same way, but it looks slightly different, so I'll do number 13 next. So let me wipe all of those. I'm sure there's a way of wiping all this. Alright, number 13. So again, our formula, inverse cosine u dot v over the magnitude of u, magnitude of v. I'm sorry, my u's and v's look the same sometimes. Alright, so let's start off with our dot product. 7 times negative 2, negative 2 times 9, negative 14 plus negative 18, negative 14 plus negative 18, 20, negative 32. That's our dot product, u dot v. Next, what we're going to do is find our magnitudes. Let's find the magnitude of u. Magnitude of u will be the square root of 7 squared plus negative 2 squared. Magnitude of v, negative 2 squared plus 9 squared. And then we're going to plug in to our formula. So theta equals the inverse cosine of our dot product, magnitude of u, magnitude of v. Not putting them in parentheses this time because it doesn't really matter, but make sure when you're putting this in your calculator that you do not put the square root of 85 inside of that square root. They are two separate square roots multiplied together. And if you put it in your calculator correctly, you should end up with 118.47 degrees. Alright, you can go ahead and try number 14, 15, and 16. They're all the same way. And then I'm going to skip to the last section that starts with problem number 17. Alright, so first, before I actually get into the problem, let's talk about what these two mean. Parallel, orthogonal, neither. Well, first, orthogonal is just another way of saying perpendicular. Okay, so perpendicular, orthogonal, those two are going to be the same thing. Well, how do we determine what they are? Well, for parallel, nope. Yeah. For parallel, if I have some vector, we'll say 2, 3, I should be able to multiply this by some value. We'll say multiply it by 3. I should be able to multiply by some value both of the numbers by the exact same number and come up with the other number. In this case, I would end up with 6, 9. So if I get these two as my vectors, 2, 3, and 6, 9, they're parallel because I can multiply one of them by some number and get the other one. If I erase that. If they are orthogonal, then the dot product has to equal 0. So orthogonal, dot product is 0. And if neither of those things happen, then it's neither. So let's go through and give it a shot. Alright, so let's start off by seeing if they're parallel. Well, 2 times what gives me negative 36? Well, 2, not 3, 2 times negative 18 equals negative 36. Well, does 2 times negative 18, not 2, my apologies. So 2. Now let's see if that works for the other one. How about 9 times negative 18? Does 9 times negative 18 give me negative 16? No, it does not. So those two are not parallel. So I need to be able to multiply both of these by some number. In this case, I tried negative 18. It worked for the first one, but it didn't work for that one. So, not parallel. Well, if they're not parallel, maybe they're orthogonal. Dot product means I multiply those two together. If I multiply those two together, I'm going to get, let's see here, negative 36 is 72. Okay. Well, actually, let me write out what I'm doing. That'd be helpful. So dot product, negative 36 times 2 plus negative 16, 9. So negative 36, that gives me negative 72. This is going to give me, I'm going to have to pull out my calculator to check it. 16 times 9, 144. Well, negative 72 minus 24, does that equal 0? No, it does not. So not orthogonal. Well, if they're not parallel and they're not orthogonal, then they're neither. So I'm going to come over to the other one. I'll leave all that there. I'm just going to erase those two. And let's check this one over here. Well, again, I'm going to start off with parallel. Parallel means I multiply one of them by some number and get the other. Well, if I'm looking at this, I know that negative 5 times 3 gives me negative 15. So negative 5 times 3 gives me negative 15. Okay. Well, the other number is 0. Does 0 times 3, does that give me 0? Well, yeah, I can distribute 3 to both of those and get this, because 3 times negative 5 is negative 15, 3 times 0 is 0. So by multiplying u by 3, I get v. So that means they are parallel. Okay, and then I'll scroll down and try number 19. This will be the last one that I do. So again, let's start off checking for parallel perpendicular. Parallel. So parallel means I'm going to multiply by some number and get the other. Now for this one, I could try to do, well, 20 divided by 8 is 2.5. So I could say, well, 2.5. See if I can distribute 2.5. But I know that if I do 2.5 times negative 8, I do get negative 20. But if I do 2.5 by negative 5, I'm going to get a negative number. In this case, I get 2.5 times negative 5. I get negative 12.5. But I'm supposed to get 32. So, not parallel. And just the fact that these two are both negative, for u, these are both negative, but v is one negative, one positive, also told me there was no way they could be parallel. So if it's not parallel, maybe it's orthogonal. Orthogonal, so dot product. If I multiply 5 times 32, I get negative 160 plus, because a negative times a negative is going to give me a positive over there, 8 times 20 is also 160, not 120. Negative 120 plus negative 160 plus 160 does equal 0. So because the dot product equals 0, orthogonal. Alright, so that is example of all three types. Go ahead and finish those out, and your homework will be due on Monday. Have a good weekend.